Hello, my name is Charlie. Today I'm going to be taking you through transcranial direct current stimulation, or tDCS, and its effect on physical performance or exercise and fatigue. Okano et al. 2015 explained tDCS as a neuromodulating intervention that modifies neuronal excitability through either depolarization or hyperpolarization of a resting potential. This is done via a weak electrical current. There are two modifying types of stimulation, a nodal, tDCS, and cathodal, tDCS. Nodal stimulation increases excitability, whilst cathodal suppresses excitability, as explained by Latari et al. 2020. According to Holgado et al. 2019, a generic tDCS setup will include two electrodes, a target that delivers a current, and a reference as a neutralizer. tDCS has the potential to last up to 90 minutes after 10 to 20 minutes of stimulation. Exercise fatigue is regulated by the central nervous system neurotransmitters. There are two types of fatigue: peripheral, relating to a loss of force at a neuromuscular junction, and central, which is the progressive failure of the nervous system to allow for maximal muscular effort. Central fatigue is what we will be focusing on. Exercise is regulated by many body systems, all of which recruit multiple physiological mechanisms, each of which elicits a specific pathway dependent on the mode, frequency, intensity, and duration of the exercise. Exercise targets multiple areas of the brain. Although a genetic motor neuron chain has been identified, it starts at the primary motor cortex, goes down the corticospinal tract, descending down the spinal cord via motor neurons, then via motor axons to the neuromuscular junction that produces neurochemical reactions to contract the muscles and produce movement. Now, focusing on the brain regions that have an impact on fatigue during exercise. Up first, we have the primary motor cortex, or M1. M1 is a network of localized neurons that initialize movements and activate exercising muscles. Mercado et al. 2019 suggests tDCS in this area may increase and sustain excitability, resulting in delayed fatigue. M1 stimulation and tDCS is a focal point of numerous studies. Next, we have the prefrontal cortex, or PFC, which has been suggested to process bodily cues relating to exercise. The PFC may have a role in exercise pacing, particularly on perceived motor output and the determination of exercise duration. It has been suggested that the application of tDCS may assist the PCF in neglecting fatigue cues and delaying exercise termination, essentially ignoring fatigue. Finally, we have what has been coined as the central command. Literature suggests a central driver that may play a significant role in regulating fatigue. This central command has been suggested to involve the anterior cingulate, insular, thalamic, and brainstem structures, according to Stein et al. 2007. It also works in conjunction with neurotransmitters and cerebral blood flow to facilitate fatigue. This area is fundamental for future research. Next, we focus on neurotransmitters' roles in regulating fatigue. The specific fatigue-related neurotransmitters we're focusing on are serotonin, dopamine, neuroepinephrine, and ammonia. High levels of serotonin are associated with lethargy and ultimately are suggested to lead to fatigue. Similarly, deficiencies in dopamine are suggested to lead to physical and mental exhaustion. This is when they are present in specific brain regions, notably the ventral tegmental of the midbrain, the substantial nigra pars compacta, and the infundibular nucleus of the thalamus. Neuroepinephrine is associated with alertness and plays an important role in the activation of the adrenal medulla, which is responsible for energy supply. Finally, ammonia. When energy levels are depleted during prolonged exercise, the production and removal of ammonia becomes a fatigue concern. The buildup of ammonium ions in astrocytes has been suggested to cause neurotoxicity and impaired cerebral circulation. This affects levels of glutamine, glutamate, and GABA, which are all related to fatigue levels. Moving on to discuss the physiological effects of tDCS. As mentioned earlier, tDCS has an impact on cortical excitability, wherein the electrical current stimulates the neurons below the electrode. This is the main mechanism underlying tDCS. In terms of current flow, the current goes along the longitudinal axis of a neuron and induces the desired tDCS polarization effect. This then polarizes the soma and axon of the neuron. Furthermore, depolarization effects have appeared to be dependent on the strength of the current and the duration of the application. In addition, research has suggested calcium and sodium channel blockers to reduce the effects of tDCS. A meta-analysis on the effect of tDCS on exercise performance suggested spinal and supraspinal factors such as a reduction in excitability of the motor neurons and the M1's inability to compensate for lowered excitability leads to a decrease in muscle power and strength, ultimately resulting in fatigue. Since tDCS is known for increased excitability, it is proposed that it may combat the issue of fatigue during exercise. One study observed a 50% longer time to exhaustion. In another, tDCS increased exercise tolerance and observed participants to perform at 80% of peak power. Various other studies suggested positive effects of tDCS on fatigue, namely an increase in exercise tolerance and time to exhaustion after tDCS. Future research should focus on stimulating areas outside the known motor regions in an effort to identify areas that may be supplementary to motor regions and may have a role in exercise and fatigue. Further, the after effects of tDCS, particularly following decreased fatigue. There was not much literature on this particularly. It would also be interesting to evaluate the ergogenic effects of tDCS regarding fatigue to observe the benefits to athletes. This may lead into how it may benefit individuals suffering from chronic fatigue in everyday life. There's so many pathways for this literature to go down. Thank you so much for your time, and here's my references.